Hello everybody. Today we're going to look at chapter 4, problem number 79. And in this problem there are two cars. One is just described as a motorist, right? And then there's a police car. And we're told that the motorist is moving 60 kilometers per hour towards an intersection, and at that particular moment he's 600 meters from the intersection. The police car 80 kilometers per hour and 80 meters from the intersection at that moment. And the question asks, in unit vector notation, so that's our IJK notation, which is very handy, what is the velocity of the motorist with respect to the police car? Okay, so we saw this in the last video that I made, the help video, that other problem, but here is again the vector arithmetic, as I call it, right? The vector arithmetic. So if I want to know the velocity of the motorist with respect to the police car, notice I'm using the subscripts this way. The velocity of the motorist with respect to the police car, MP. Okay. I need to add the velocity of the motorist with respect to the ground plus the velocity of the ground with respect to the police car. The way you could look at it is that when you combine these two quantities on the right, the G kind of cancels out and you're just left with motorist with respect to the police car, which is what you want, okay? But you've got to have it arranged that way. If you just add the velocity of the motorist with respect to the ground and then the velocity of the police car with respect to the ground, it'll be backwards. It won't work. And so here's the key, here's the trick, right? The velocity of the ground with respect to the police car is the opposite of the velocity of the police car with respect to the ground. What does the problem give us? The problem gives us the velocity of the police car with respect to the ground. And based on the diagram they have, and here I drew a diagram, always draw a diagram. Well, first of all, what are we expecting? If we're in the police car, the motorist looks like he's moving to the left, right? So you can picture yourself as in the police car. The motorist looks like he's moving to the left, and you're moving towards him. So that's going to be on this axis, using this axis, right? Since the motorist looks like he's moving towards him, positive x, right? Or positive I quantity, and then looks like it's moving in the negative y direction. That's what I'm expecting to see, right? So let's do this. So the motorist, using the vector notation, the motorist is moving. Let's do this in blue. So the velocity of the motorist with respect to the ground is negative 60 kilometers per hour, J hat, right? And then plus, now the velocity of the police car is in the negative x direction, right? But then I'm subtracting that, right? So it ends up being positive, and so we get 80 kilometers per hour in the I direction. Okay, and that's what I expect, right? From the police car's perspective, it looks like the motorist is moving towards him, positive x, and the negative y direction. This is the answer, but just for the sake of convention, we usually put the I first, IJK. So we can simplify this and say, so the velocity of the motorist with respect to the police car is 80 I minus 60 J kilometers per hour. I'll put the units that way. So that's the answer to part A, by the way. Part B asks, for that instant where they are, what is the angle between the velocity found and the line of sight? So the line of sight, the police car is looking, let's do this in green, this way, and the relative velocity, he looks like he's moving in the opposite direction, right? He looks like he's moving, so it's the negative J and the positive I actually looks like it's going that way. And if you look at the positions, it's the same ratio, 60 over 80. and then 600 over 800. And so the answer is 180 degrees would be that the angle between the line of sight and the velocity is going in the opposite direction. And then C asks, as they get closer together, does this change? And the answer is no. The velocity, first of all, the ratio of the velocity doesn't change. That stays consistent. And same thing with the line of sight. So the answer to C is no change. So that's it. Hope that helps. Don't forget to like and subscribe.